I'm Bob Zimmer, and today we're going to be talking about data-driven decision-making in the PepsiCo fleet. So I am the Supply Chain Fleet Technology Senior Manager for PepsiCo. I've been with PepsiCo for 12 years and have 34 total years of fleet experience, including with UPS, GM, Wheels, Daimler Hertz, Frito-Lay. I hold all of the ASE master certifications that are currently available and have kept them up for quite a few years. I'm also a graduate of the General Motors ASEP Technician Program and have been a GM dealership technician for about 3 years outside of that program after receiving my degree in automotive technology from Triton College. I speak English, but program in many different languages, and my team keeps up with all of them as well. I'm also a Microsoft SQL Server data architect. The Frito-Lay Pepsi North American fleet is the largest fleet in North America. We have 70,000 total assets. And as you can see here, these assets are extremely diverse, from yard tractors to trailers, to straight trucks, to tractors, delivery vans, even material handling equipment. All of these pieces of equipment provide certain level of data, whether that's data coming off of telematics devices, data coming off of the CAN bus, data coming off of installed sensors. Normalizing these data streams so that we can scorecard a location which may have representation of each one of these classes of assets is extremely difficult and time consuming. In terms of our products, I'm sure that all of you are familiar with our top global brands, as well as our Better For You, Good For You, and Fun For You brands. When we talk about data, we're talking about different data types. This presentation is going to focus on asset level data. Asset level data is broken down into a few subcategories. The asset level data we have begins with our engineering specifications. We build our own trucks, we spec our own trucks. That allows us to get exactly what we need to deliver the particular product that we need. Some of our product is literally bags of air, very light. So we need maximum cube to deliver those products. Some of our product is very heavy, liquid. So we need maximum weight bearing capability. We then go on to geolocation. So geolocation is where the asset's actually going to be used, where the asset is deployed to, where the asset's supposed to be deployed to make sure that as spec, those assets are delivered and being used as intended. Then we have maintenance history. Maintenance history is really the key for reliability, warranty, safety, productivity. Our technicians need to know what's been repaired, what's been replaced, are there any trends in failure in order to make sure that that asset remains reliable and safe. Fuel transactions. Fuel is our #1 expense in bringing our product to our customers. So maximizing our fuel economy by looking at our fuel transaction data is a key driver of fuel productivity. Telematics and fault codes. Telematics and fault codes are a little bit different than geolocation because now we're looking at specific pieces of information coming through the telematics gateway, which is CAN connected to every asset. Fault codes can identify a problem before it becomes a reliability or safety issue to our technicians. Driver trip records. Driver trip records are extremely valuable in that we're getting basically a walk around inspection every time that driver begins their day and ends their day. So twice per day, we have driver trip records coming in to our asset level data, which can indicate the beginning of an issue, which could result in safety or reliability concern. So while we've talked about the type of data, we need to talk about capturing and curating that data to maximize the value creation. So really, it all starts with solid data integrity, integration, and a foundational structure. The #1 key point that I want to drive home here is that you must own your data. Confidence in the quality of your data is crucial to driving cultural change. If your users do not trust the integrity of the data that they're being presented, they will not use what you are creating for them. We need to make sure that we track everything down to the truck level. It's very easy for us then to aggregate up into the different locations, regions, manufacturers. Excluding trucks with bad or incomplete data from analytics only leaves us with a blind spot, which can potentially be our riskiest trucks. Again, data without integrity is just numbers. So how do you take the big data and deliver it to the masses? Well, first, you need to have a big data platform. We have a big data platform that we've affectionately nicknamed TAD, and that stands for Tableau Asset Day. In this data platform, we have one record per asset per day. And that record then has all of the individual metrics that we're measuring from all of the different data sources that give us information on that asset. At the time of this presentation, when it was put together originally, we had 140 million rows of data already stored. Full lifecycle analysis is definitely possible when you have all of that information in a normalized form. When we talk about some of the types of data that we put in to TAD, the odometer reading and KPI for every asset for every day of its life. Every asset we've touched since 2008, we have an accurate odometer reading on. And when we have gaps, we have algorithms that can smart backfill the missing odometer readings and put the chains to the link back together. So to our knowledge, no one has this much fleet data, and we're just getting started. This allows us, for everyone from our engineers to our technicians in the field, powerful decision-making tools, which allows them to focus their efforts to maintain our world-class fleet. So what are some of the questions that we're able to answer? Well, we have organizational strategy, priorities, and culture, right? We know what our current equipment profiles are. We know how many assets that we'll need at our current life cycle, and I'll expand on that in a moment. We know which assets to replace, and we know where to put them. We know what we should buy next, as well as what we shouldn't buy next. And then what's the cost savings or even the risk worth? So when we talk about life cycle management, fleet age by asset spec, by business classification and application, we have an asset class and subclass which we can use to normalize for our replacement strategy and identify buckets of performance opportunity. You saw originally we have all these diverse types of assets. By using subclass, which is a group of managerially relevant data points that can identify a specific make, model, year grouping of like assets, we can then measure these assets against their peers in their subclass within a location, a region, a division, and put everything into one scorecard, which now makes sense. For example, if we have, let's just say, a 16 mpg asset that's achieving 14 mpg, and we have another asset in that same location that is a 12 mpg asset that's getting 14 mpg, we might say that, well, at face value, they're both doing great. They both get 14 mpg. However, when we look at the subclass, we see that the subclass for the 16 mpg asset, that they're getting 16 plus, yet this asset's getting 14. And the subclass for the 12 mpg is getting 14, and that's doing great. So really, when you strip back and you have those data points available to you, you can identify that the asset that is getting 14 mpg in the 12 mpg subclass, that's your rock star, and the other asset is your opportunity. So we talk about forecasting replacements for life cycles. If you kind of look at kind of the trend, it used to be where we would have assets aging, and in the past, typical fleet says, hey, let's just replace the oldest assets first. That makes sense, right? But if you actually look at the modeling based on average age, cost, reliability impacts, capital constraints, business changes, you may find that replacing assets that are not your oldest assets might be a better strategy. Those older assets, they're running just maintenance. They may have great reliability. They may not require major repairs repeatedly. Yet you may have assets that are 2, 3, 4, 5 years newer. And because of the data that you've got collected now, you can identify repair trends, failure trends for these assets where they're actually forecasted to cost you more. So it's beneficial for those assets to be replaced before the older assets, and the data tells us that. When we look at kind of fuel, obviously I said it's the most expensive piece of bringing our product out to the consumer. Fuel is really important. So you need accurate MPG for every asset to maximize your investment dollars. We need to develop inputs for both tactical and strategic action plans so that when we see underperforming assets within subclass, we can either phase them out, or if it's a driver training issue, we can train the driver in how to drive in a more impactful way so that they can have higher MPG. We have our technicians, which first look at the asset to say, hey, is there a fault code? Is there anything that would be a mechanical reason why this asset may be underachieving within its subclass? So we develop a specific fuel intervention that starts there. And if nothing's found there, then we move into the behavioral side where it could be a driver training issue. So when we talk about the impact moving the average age of the fleet, the common question is, what if we don't buy trucks? How do you estimate the cost impact of your fleet? It may make sense to skip a year. If you have opportunity where we have high performing, highly reliable assets, we can move that capital for use elsewhere in the company and come back and say, look, you know what? We're going to put a hold on buying this year for these reasons. And we can actually quantify those because of the data that we've now collected. We look at reliability, right? The common question is, what does a breakdown cost? And the answer is, how much time do you have? When we talk about really what does a breakdown impact, first of all, it's not just about now I've got to tow a truck back to the shop. That truck should leave on its own and come back on its own after performing its route. When we have a breakdown, first of all, I need to send another truck to offload all the product on the existing truck on the side of the road. Then I need to send a wrecker to tow that truck back to our location, hopefully, unless it's way past our location's boundaries. And now I've got to tow it to an independent vendor, which costs exponentially higher for the repair. Now I've got to pay extra for parts and labor. I would typically miss a few stops on my route for that day. So now I've got some customers that are impacted, potentially lost sales, potentially aggravated customers from not having their product at the time they need it. I may miss delivery windows. So there's a lot that goes into that. Plus, I'm also paying my driver now overtime because they're going to have to play catch up to make the deliveries that they initially missed because they're waiting on the wrecker on the side of the road. So when we talk about the historical life-to-date cost analysis, when we look at the data points for every asset for every day, and we look at spend over odometer reading, which is on the left-hand upper side, we can see that the assets in red, which are, if you look at the odometer reading, newer assets, they are trending higher in spend versus the older assets, which are now just in maintenance mode. So if we look at identifying assets that we could potentially replace, those assets that are trending in red over time are going to cost us significantly more than the assets that are trending in green. We can use this data to prove that those assets will need to be replaced prior to the older assets, which kind of goes against common thinking, but we have the data to prove it and it actually works. When we talk about asset utilization, we're talking about the telematics piece of it, right? So the telematics piece gives us literally an overview of where our assets are being used and when. So Question, are technicians staffed when the trucks are available? And when we look at the upper right-hand graph, we can see that over time, that's a graph of asset utilization by hour of day, by day of week. And we can see that the proper timing to have our technicians on site is when we're at 50% saturation or above. So it may go against standard thinking of, well, we want the technicians working 8 to 5. Well, if our trucks are available from, let's just say 2 p.m. to 2 a.m., we may want to adjust our technician start time so that the maximum number of trucks available to either repair or PM or inspect are on the lot. We don't want the technicians clocking in 4 hours before the majority of the trucks get back. We also want the technicians on site when the trucks do return, so that if on that post trip, the driver finds an issue, we can have them talk to the technician and get that truck repaired quickly overnight before that truck needs to be used again the next morning. And we have to put the driver in either a rental or a spare. We talk about reliability, our last topic. Really, when we talk about reliability, in the past, it was a reactive focus, right? Emergency repairs, PM's not being completed on time, equipment's failing, a negative impact on the business. Well, we really want turnkey truck runs, world-class reliability. We need to move to a reliability-focused approach with effective analysis, planning, technician scheduling, which all of that data that you just saw drives. It has an extremely positive impact on the business results. The PMs and follow-up repairs are completed on time, which gives us reliable equipment. And reliable equipment leads to safe equipment, leads to productivity, leads to better MPG and happier drivers. Fewer rentals, fewer spares, so we don't need to keep as many assets on the lot. Allowing our data to flow and be available to all of our technicians and all of our site managers drives reliability. But caution, reliability at any cost is not sustainable. When we talk about predictive failures as well, we can use the telematics signature to give us identifiable signatures of a pending failure, and we can act on that, get a technician a work order prior to that failure occurring, and have the technician replace whatever needs to be replaced, or do an electrical PM and figure out, is it a battery, is it a corrosion issue? But bottom line is, we're using the telematics data, and we're using machine learning and algorithms over that data combined with our work order data to then build a predictive model to get that information in front of the technicians and in their hands. Again, same thing, duty cycle issues we have with our trailers, making sure that they come back under their own power with lift gates still working under their own power. Could be an opportunity for a solar panel to charge. Again, we really need to look at the data and have the data deliver the results that we need based on looking at different duty cycles. And that is my presentation.